Hello, my name is Josh Bendorf. I'm the Precision Ag and Conservation Specialist with Pheasants Forever, Quail Forever in southern Wisconsin. Today I'm going to be talking with you about the work that I do as a Precision Ag and Conservation Specialist, the Precision Ag and Conservation program that we have going in Pheasants Forever and Quail Forever, and I've titled this presentation, Data Working for Profitability and Sustainability. So just getting into a little bit of background about Pheasants Forever, Quail Forever. For those of you who aren't familiar with the organization, it is a nonprofit organization that was founded in 1982 by some concerned landowners and hunters who noticed a correlation between a decline in upland grassland habitat where pheasants and quail like to live, and a loss of the bird population. So as the amount of grassland acreage was decreasing, notice the amount of birds was also decreasing. And so what they wanted to do was to help get some of those acres back on the ground and help preserve the grassland that was still existing. And this is in part why Pheasants Forever, Quail Forever has been dubbed the Habitat Organization due to the extensive amount of upland grass habitat work that the organization has done. Some other things that Pheasants Forever, Quail Forever is actively involved with is creating public hunting access on private lands for avid hunters, for people to come and either in-state or out-of-state to come and spend their dollars locally and have fun in the great outdoors. Also involved highly in environmental education, educating adults and youth on being good environmental stewards, conservation advocacy, both at the state and federal level. Pheasants Forever, Quail Forever employs a diverse staff of folks, folks like myself, precision ag specialists, but we also have our farm bill biologist positions, tend to be more focused kind of on more of our the wildlife side of things. We have folks who are specifically dedicated to doing environmental education and conservation advocacy, our program coordinators. So we have a lot of different backgrounds, a lot of different talents that comprise our team. We also have a unique chapter model. So if you're familiar at all with Pheasants Forever, maybe you've heard of your local Pheasants Forever or Quail Forever chapter. Here's a map, the most up-to-date map of our Pheasants Forever, Quail Forever chapters in the state of Wisconsin. And so our unique chapter model is that our chapters, all the dollars they raise, they can determine themselves what they want to do with those dollars. So through their fundraising events or youth hunts or things like that, raising those dollars, they decide what they want to do with those dollars. Some of those dollars come back to help fund positions like mine or biologists or doing habitat work. A lot of these groups will do habitat work on their own, controlled burns, grass plantings. They'll maintain no-till drills that folks can use to do grass plantings. So these groups are highly involved and help fund positions like mine to keep increasing the amount of grassland habitat we're creating in Wisconsin. So with that, let's get into precision agriculture. So what I've described so far, you might be thinking, and you'd be right, that Pheasants Forever, is a wildlife-focused organization, focused on wildlife conservation and habitat establishment. So why would a wildlife organization care about something like precision agriculture? What is that? That seems like something that's, very far removed from, wildlife conservation, two very different subjects. So how are those related? Well, I like to trace this back to pre-establishment day, settlement days here in the state of Wisconsin. And looking at the amount of grassland that we had pre-establishment and up to the point where we are now. So historically, there were 2.1 million acres of native prairie in the state of Wisconsin. This is before Europeans came and settled here in the state in the mid-19th century. But today, less than 10,000 acres of native prairie remain, and they tend to be in small patches of 10 acres or less. And so one program that was enacted in part to help get more native plants back on the ground, create grassland habitat and to conserve our soils and to promote soil health was the Conservation Reserve Program, or CRP, that was created in part of the 1985 Farm Bill. In this program, farmers are paid an annual rental rate from the USDA to take acres out of commodity crop production, so corn, soybean production, and to put those acres back into grass. And so looking at these two graphs, this is data from the FSA, the Farm Service Agency, through USDA. The upper graph is CRP acres in Wisconsin, and the lower graph is CRP acres in the US from the initial start of the program in the mid-80s up to 2020. And so what we see here is that initially the program, once it kicked off, acres rose quite rapidly. And in the state of Wisconsin in the mid-90s and early 2000s, kind of plateaued at about 600 to 700,000 acres. And in the US, they topped out at about 30 to 35 million acres. And stayed roughly around those values up until the mid 2000s. And on a national level, we hit a peak of just over 35 million acres of CRP in 2007. However, since roughly 2007, 2008, CRP has been on a decline, both in the state of Wisconsin and on a national level. So in the state of Wisconsin, 2019 CRP acres were less than 50% of pre-2007 levels. So we see in 2007, we were at roughly 600,000 acres. Now down 2019, 2020, we're now down to 200,000. And similarly, in the overall United States, we've now dipped below 25 million acres of CRP for the first time since the late 1980s. So CRP acres are on the decline. So a program that was initially created somewhat to help get more grassland habitat back on the landscape is now not as effective. Several reasons I have seen for this. A big one is around the year 2007, grain prices are really good for corn and beans. And so the prices for growing a commodity crop were higher and more profitable than doing CRP. So the CRP payments were not as competitive. And so acres that were expiring in CRP, these are roughly 10-year contracts. Once those acres expired, they were put back into production and commodity crops. They were not re-enrolled. But one thing I would like to note here is that CRP does not just include grassland. It includes both kind of grass and forested practices. And so if we just take in 2020 in Wisconsin, overall CRP is roughly 200,000 acres. But if we only consider grassland practices, so buffer strips, waterways, things like that, we see we dropped to about 168,000 acres. So even less than what this graph is showing. So this brings up a conundrum for these pheasants with their, they live on these agricultural landscapes, and and especially during the winter months, they need a place to shelter from the cold and the snow. But in a case like this, we have just an open cornfield with no grassland around. They don't have that. They don't have that option. They don't have that shelter. And if pheasants don't have, and other wild birds don't have that habitat during these cold winter months, their survival rates are not very high. And then during the warmer months, that's also their shelter and a source of food for them when they eat insects, things like that. And it provides good brood rearing habitat for their young. But if we don't have those grassland acres, they're gonna struggle to survive. So how do we gain those grassland? How do we gain some of that grassland habitat back that we've lost? So this is where precision agriculture comes into play. So across the field, let's use this field as an example. This is a image from Purdue University Extension. So looking at a field such as this, if we have an idea of how this field is yielding as a whole. If we know how much yield we took off of this field, let's say this is a cornfield, and so we know how much corn grain we took off the field, how many bushels, and we know how many dollars of input we spent on this field. So management, tillage and fertilizer, harvest costs, planting costs, the cost of storing the grain or transporting the grain to the co-op, you know, things like that. We have an idea of how much we spent to produce a crop on this field, and we know how much crop we took off of this field. So we get an idea of, on a whole field level, maybe how profitable this field is. And we know that, for example, let's just say we know how our profit from our yield was higher than the inputs that we spent on this field. So that's why I have this field kind of shown as green, because it's profitable. It's net positive in terms of return on investment. But if we just consider the field as a whole, I've made this box transparent for a reason. We can see if we just assume it's all homogeneous and we say the whole field is equally profitable, we're ignoring things that are clearly going on behind the scenes here underneath, kind of like what I would call this kind of as a green mask. You know, it's hiding the heterogeneity that's going on behind the scenes here. So how can we get an idea of all those different things that are going on in this field? Well, this is where yield monitors come into play. And so as the combine goes throughout the field, makes a pass and harvests the grain, it tracks how much grain is going through the machine and gets an estimate of how much yield you're getting for each one of these pixels as the combine moves through the field. And what it shows up as is a mosaic of yield at a very fine resolution across this entire field. And if we have an idea of how much input we spent on each acre of this field, we can set this map up in a way so that any acres that are showing up here as red, there's not a color bar provided for this image, but if we just assume that anything that's showing up here in red is an area where we are below our break-even yield, or the yield point at which we're making as much money as we spent to produce a crop on these acres. So although as a whole, if we look at this field, this has one single chunk, this field is showing up as profitable, we can see here that that is not the case at a finer resolution. That maybe, you know, a lot of the field here, you know, we have greens and yellows, areas that are profitable, and light orange. But once we start getting kind of these darker orange and these red areas, these are areas where we are not making a profit. These are areas where we're spending more than we're making. And if we layer these maps on top of each other, I mean, this is just 1 year, but if we were to layer this on top of several previous years, we can start to get an idea of where the field isn't doing well year after year after year. And so this brings up a question: how do we address these areas? How do we, you know, take those red areas and make them green? How do we turn red acres green? And so this is where I come in. This is where our precision ag and conservation specialists really get to shine and show, and use our agronomic and environmental knowledge to find solutions for those red areas. So how our process works with the producers that we work with, the vast majority of the producers that we are working with, at least here in the state of Wisconsin, are collecting yield monitor data. So not every farmer collects yield monitor data. It's newer technology, and it's steadily being adopted, but it's becoming more and more common. And a lot of the producers that we have worked with are collecting yield data and have been doing it for several years. So these producers will grant us access to this data through whatever data platform they're using. There's several of them, and we'll be able to access this data and using the yield data, and then working with the producers using their budget data. So we'll sit down with the producer and kind of, go through the books a little bit. We'll figure out, how much they spent on fertilizer and planting equipment, harvest costs, storage costs, any other field management cost. We'll sit down and we'll pencil out all those costs. Or if they're not comfortable sharing that data with us, we have estimates from University of Wisconsin Extension that provide good estimates. We don't want to push the producers to a point where they're not comfortable, but the caveat being the most accurate data is going to be which is being collected on the farm. So by layering that budget data that we collect from the producer and the yield data that they've shared with us, we can then create profitability maps from those yield maps where, like I mentioned before, we can set the color scheme on these maps in such a way where any areas here that show up in red are below our break-even yield. And so once we've identified those areas that are red year after year after year, or are highly variable and might only be good once every few years, depending on if it's a really dry year or a really wet year, these are areas where we block off and we start to think about what we want to do different on those acres. And this is where we kind of take off our agronomist hat and put on our conservationist hat. And we start to think, from an environmental and economic standpoint, what's going to make sense for those red areas. So for example, maybe we could do a planting here, some native plant species, some grasses and some forbs, like maybe along one of these edges, for example. Take that edge out of production and put in nice patch of black-eyed Susans, and other native species that are going to be good for pollinators and are going to make good habitat for grassland birds like pheasants. Or for example, down here, this image, I believe what we're seeing here is kind of a taller stand of just maybe some native grasses, maybe some switchgrass or things like that. Something that's going to provide good brood rearing habitat, but is also going to provide some shelter for these birds, during those cold winter months. Something with good stiff stems that's going to hold up to a harsh winter like we get here in Wisconsin. And so by combining this agronomic and economic data that we get from the farmer and using our knowledge of conservation and wildlife habitat, we can find solutions that make sense from an economic, environmental, and agronomic standpoint, where we have our highly productive areas here still in production and whatever commodity crop the producer's growing. But then adjacent to that, in these red areas, we have a stand of habitat that's going to be good for a plethora of things. So these habitat areas provide multiple benefits, these upland grassland areas. Excuse me. So the big thing, we're looking at with the producer, is profitability, looking at, kind of things from like an agronomic and an ag business perspective, what's going to help, increase that farmer's bottom line in that field. Obviously, we don't, a big step towards doing that is taking those red areas just completely out of production and not continuing to throw money away on those acres. But by taking those areas out of production and establishing some grassland habitat, we see, obviously, as from a wildlife organization standpoint, we're thinking of, creating, habitat for wildlife, for upland birds, and for pollinators. Those are gonna, these grassland areas, especially, those that have a good diverse stand of forbs, flowers, are going to provide great habitat for our pollinators, which are going to be good for our nearby crops like soybeans or vegetable crops, for example. It's also going to provide some good, good habitat for wildlife and help maintain healthy bird populations. But there are other environmental benefits as well that are coming, that are going to come from establishing grass. One is improved soil health. So by having a diverse stand of native or maybe introduced grass and forb species on the landscape, and having that good root structure in the soil, we're going to improve soil structure. Maybe help some address some compaction and erosion issues that we've accrued over several years of highly managed row crops. Be good for soil biology, so a diverse plant stand promotes good microbial biology, diversity in the soil, and then building organic matter through many years of intensively managed annual crops. They're putting a perennial back on the landscape, so something that's going to have a longer growing period and is going to continue to put on, deep root biomass. It's going to help in litter. It's going to put down a litter layer as well. It's going to help build up that organic matter, which also tends to be reduced, greatly reduced in some cases after years and years of intensely managed row crops. Water quality benefits can be seen from this as well. So if we look down here at this image in the lower hand corner here, we see a field that slopes down towards a stream that runs through this wooded area here. And so by putting a grass filter strip, a buffer strip here along the edge of these trees, water that flows from the field down to this stream, that grass is going to help slow the overland flow and catch sediment, but also any water that percolates down to the soil to the stream, that living root material will help take up some of the excess nutrients left behind by the commodity crop, and it'll help filter those out before that water reaches the stream, the lake, or whatever other waterway we have here. These areas like along tree edges tend to be some of our commonly found red acres due to shade, wildlife pressure, soil, other several reasons. But someone like myself, my educational background is in agriculture, crop production, and climate. Carbon sequestration is something that gets me really excited about perennial grasses going back on the landscape. Annual crops do not have, a very long growing period. They don't put down a lot of root material. There's not a lot of biomass left behind after harvest in many cases. And so, we're not putting much of that litter back into the soil. And that litter is what contains carbon, which has been captured from the atmosphere through photosynthesis. And so that carbon, is it going to be put back into the soil, or is it going to be removed or sent back out as CO2 through soil respiration? When we have a good stand of perennial vegetation, perennial grasses that have a long growing period and put down deep roots and continue to put down roots year after year, as that root material and the litter decomposes, it is stored in the soil as soil organic carbon, which is a major component of soil organic matter. So that organic matter gain is actually carbon that's being taken out of the atmosphere and put into the soil. And so through increasing, our root material, the amount of litter we're putting back into the soil, the less amount of times we're disturbing the soil, because disturbing the soil will also release carbon. So by reducing that and increasing the amount of biomass we're accruing through perennial vegetation, we're increasing the amount of carbon we're sequestering on farmland. And to me, all of these are very big deals. So just briefly running through what the consultations with our producers look like. So we function very similarly to how a crop advisor or an agronomist would function. I think of ourselves, as conservation crop advisors. We function very similarly to how a traditional crop advisor would function, but we do it kind of more from a little bit different angle, from a conservation and grassland establishment angle. So the main thing we'll provide to producers is technical support. Our support services are unlimited. They come at no cost to the producers. We'll work with whatever data platform they're using. So like I mentioned before, there are several out there that you can use to analyze yield monitor data. Some of them now, especially some of the cloud-based ones, you can easily share that data with your agronomist or someone like myself and a different advisor. any one of your trusted advisors you can share your data with, and it's very seamless, I will say. But in some cases it might be a little bit more tricky depending on what they're using. But we'll sit down with the producer and we'll find out a best management plan for us to share data. And we will never push a producer to a point where they're not comfortable. If they don't want to share something with us, that's totally fine. We'll do what we can with what we have. Like I said, our services come at no costs. Thanks to our great partnerships that we've established with industry partners and university governmental partners, which I will mention here shortly. All the programs we look at are voluntary, so we'll help navigate the producers through some funding opportunities for establishing these grass areas. So we're aware that even though you'd be taking a unproductive area of the field out of production and putting in grass, establishing grass still has cost associated with it. And so we want to make sure that we let the producers know there are opportunities to help cover some of that cost and share some of that cost. We are NRCS partners for the USDA, and so we'll help navigate the producers who are interested in going through a USDA program such as CRP or the EQIP program, CSP. These are things we'll help navigate the producers through and direct them to their local field offices if appropriate. But there are also potential access to exclusive funding opportunities. The main example that comes to mind for me, is the producer-led watershed groups through the Wisconsin Department of Ag, Consumer and Protection Services, DATCAP. And so through these groups, some of these groups will have their own unique funding opportunities to establish cover crops and do other conservation management practices. And so if the producers are within those watersheds, they could be eligible for those programs. And then some county land conservation offices will also offer some cost share programs, and we'll walk through those with the producers as well. And really the key thing is, to find those solutions, to find voluntary solutions for those red areas that make economic, agronomic, and environmental sense, which will in turn further the mission of Pheasants Forever, Quail Forever, which is to get more grassland habitat established back on the landscape and help support healthy wildlife populations, healthy soils, healthy water, healthy air, checking as many boxes as we can. So like I mentioned before, we have partnerships with a wide array of partners, both out in industry, through governmental organizations. Like I said, here in Wisconsin, both of our precision ag and conservation specialists, as well as all of our farm bill biologists, work out of NRCS offices. We're very close partners with the NRCS. We work a lot with them, but we have a lot of other partners across the Midwest. Colleges, universities, departments of agriculture, natural resources organizations, a wide array of partners here that help fund our positions and help make our work possible. In particular, I'd like to point out that we are partners with the organizations that maintain and produce the commonly used precision ag platforms that our producers that we work with use. So the Climate Corporation has FieldView, John Deere has the Op Center, Granular has Insights, TrueTerra has their own program. And so being partners with these organizations is very important to us, because not only can we get some technical support from them when we are working with a producer and we maybe hit a snag with the program, we're not sure how to do something, but we can also provide helpful feedback to these organizations to know how their programs are being used in the field and how useful they are, and so we can help make these programs better. And with that, I would just like to get into a few examples from the farm that some producers that myself and my counterpart Scott Stipetich up in northern Wisconsin have been working with. over the past 2 years that our program has been going here in the state. So our first example is a producer from the southwest part of the state in the driftless region, one that I have been working with just starting in the summer of 2021. This is a producer who had been collecting data using Climate Field View and Case IH operating system for several years, going back to 2017. So he had 4 years of yield data for me to work with in his fields, had both rented fields and owned fields that he was working in. For the most part, his fields were quite productive. He farms in a very productive agricultural region in the southwest. But this is one field in particular that we spend a lot of time talking about. So you see here, he had 1 year of soybeans and 3 years of corn data. His average corn yield over those 3 years was 212 bushels per acre, and his average soybean yield was 53 bushels per acre over just 1 year. And so overall, yields are pretty good. And the way I have these maps set up is once I worked through the budgets with this producer and we found what his break-even yield point was. I then set these maps up in a way so that any pixels that had yields below that break-even yield point showed up as red. So in these maps, red equals negative ROI. And so what we were noticing in these fields is that these corner regions here in this kind of right triangle shaped field were showing up as red year after year to some different degree. It wasn't maybe necessarily a consistent block, but within these areas here that I had, these polygons that I had denoted within field view, that we were seeing pretty consistent red patches in those fields. Talking with this producer, he told me these areas are tight for his machinery, so their management is hard in these areas. And then with tight turning, there was a lot of vehicle traffic, a lot of pivoting over those areas. And so there was some soil compaction was going on in those areas as well. And I confirmed that by going out to the field and observing some substantial soil compaction that was going on in those corners. And this was leading to some decreased productivity in those spots. This producer, he does variable rate inputs. So precision ag includes a lot of different technologies. Yield monitors are the ones that we use the most in this job to create these profitability maps. But excuse me, variable rate planting and fertilizer application is another example of precision cropping technology. And this producer had he had adjusted his seeding rates and his fertilizer rates in those parts of the field to help reduce some of his input costs. He knew he was going to get lower yields in those corners, and he wanted to try to make those areas more green by reducing his input costs. But you can see it was not successful, as these areas they're still showing up as red. And so from those 4 years of yield data, I was able to create profitability maps. And so those two corners that I was mentioning in the last slide, blocking those areas off, roughly 1.5 acre areas of the field, showing up as anywhere from about -$42 per acre to -$65 per acre. Both those areas over 4 years were net negative in terms of return on investment, whereas the main chunk of the field, this roughly 14 acres, was making around $83 per acre. So overall, those two areas that we blocked off were red acres. But we notice here there are some other areas here in this field that are showing up as red, some patchier areas within the kind of the the main body of the field. Some of this along the edge here is due to some overlap from passes as he went horizontally and vertically, and then came across diagonally. There was some overlap areas where the machine thought less material is going through the combine, when in reality it's just because there was only a part of a row there. So tend to kind of have to visually pick out those areas. So that's why we didn't pick out that edge, but we noticed that there are some patchier red areas going on here in the main part of the field as well. So how do we want to address this field? Still in the planning process with this field. I've only begun working with this producer just a few months ago, so we're still, nothing has been done yet. But for those red corners, which are losing money, are tough for management. The plan is to take those areas out of production and establish some grassland habitat. This producer was interested in just doing some cool season species, a mix of some cool season grass species for those areas, which are gonna will help address some of the soil resource concerns he has going on in those areas, as well as increase overall profitability by not farming those areas, as well as providing some habitat. For those green acres, like I was mentioning, although it's showing up as overall net positive, there are still some patchy red areas in that part of the field, and profitability isn't as high compared to the rest of his farm. So thinking through some ideas, and he wants to experiment with cover crops to help increase yields in this part of the field through building soil organic matter. So he has a plan to do some oats and tillage radish this fall in this field to help rebuild some of that soil organic matter, and to help both reduce inputs and help increase his yields. The second farm example is from a producer, a dairy farmer up in northern Wisconsin that my counterpart Scott has been working with. This farmer had data, yield monitor data that he collected from his corn silage chopper, so not corn grain in this case, but silage as forage for his dairy herd. And he had been collecting this data through John Deere and Granular. And through 3 years of data layered on top of each other here, using the John Deere Ops Center data platform, Scott was able to analyze that this field overall averaged around 62, I think 62 tons per acre. I'm not sure on the units there, but the overall profitability of this field was $134 per acre. So again, a field, as we look at it as a chunk, overall is profitable. But we can see here he's had this yield map, so anything here in red is net negative in terms of return on investment. So by blocking off that edge, determine that overall in these green acres, these 55 acres, I misspoke before. It's the average yield is 5.5 tons per acre. The acreage was 62. So overall, our field here was about 55 acres. That was profitable. Average yield about 5.8 with a return on investment of $170 per acre. But on that edge, that 7 acres, our yields went from 5.8 to 3.3 tons per acre, and we're losing almost $150 per acre over 7 acres. So that's an area where we're losing quite a bit of money on an annual basis, and an area where some alternative management should definitely be considered. So the alternative management that this producer went with, like I said, he is a dairy producer, so he's interested in forage. So he converted those red areas from corn silage to a hay planting. And in doing so, he kept the profitable areas in production at 55 acres that was making $170 per acre. But then on those poor acres, that 7 acre strip around the outside, or we see here, I don't know how well this is showing up, but there was some deer damage and some shade issues from these trees going on that was causing some low yields. he went from minus $150 per acre to plus $85 per acre. So maybe a little counterintuitive, but by taking your main cash crop out of production on some parts of your field and putting in grass, hay, forage, you actually increase the overall profitability of your field. And on a field scale, he went from $134 per acre to about $144 per acre. So a $10 per acre increase over a roughly 60-acre field. So quite a bit of gain in profitability just by taking that red strip out and putting in a hay planting. And that hay planting is also going to provide good habitat for upland birds and pollinators, and is going to help. I believe this field was sloping this way, so anything, you know, as water leaves the field, it'll flow through that grass strip. It'll help to stabilize the soil, build organic matter. All of those benefits that I mentioned before can be gained with this hay planting, or a grass, or just a general grass planting along that strip in general. So with that, I just want to leave you with a few references and my contact information. I am based out of the NRCS office in Juneau, Wisconsin, in Dodge County, and my counterpart, Scott Stipetich, is based out of the area office, NRCS area office up in Altoona. I cover the southern part of the state. He covers the northern part. So between the two of us, you know, we provide coverage to the entire state of Wisconsin. So if you ever are interested in working with us, with our precision ag and conservation specialist, or Pheasants Forever as a whole, please feel free to shoot me an email, give me a call. Always available. Follow me on Twitter at Josh Bendorf 95. I tend to post. I try to post some relevant, up-to-date information on conservation agriculture. And check out our website, our precision agriculture landing page on our Pheasants Forever national website. We have some good success stories there. More talk about our partners, and you can see our national team there. We have about 13, I think now 13 of us across the United States as of summer 2021. So yeah, thank you again for listening today, and I hope you found this talk useful.